everything. Okay, these first four really just represent the operations of math, right? They're the operations of math. They're just words that we use to represent those operations. What are the four operations of math, Maggie? What do these things mean? What?
Why are you putting me on the spot?
I'm just asking you. What do these words mean? What are the four operations of math? You don't know what those words mean? Are the four operations of math? Jesse, do you know? Any of them?
Well, I mean, isn't the sum?
Addition, subtraction,
Yeah, that's it. It's the real
Like
simple stuff.
adding.
Yes, that's why I asked you, as I figured it's just simple. So she's right. Did everybody hear what she said? Go ahead, Maggie, say it again.
Addition.
Addition is what?
Even in division.
Addition is sum. I'm just going to put a plus because I don't like to write. Okay? So if it was me, I would just put a plus there. What's difference? A subtract. I'm just going to put a minus there just so I don't have to write it. And what's product?
Adding?
Nope.
No.
We already said adding.
Multiplication?
It's multiplying, yeah. And what's quotient?
Dividing.
Division. So anytime I say these words, these are just the language of math, right? When I say those words, I'm really just talking about the field operations. These are the only operations we use in math. You may say, well, wait, don't we have exponents? But what's exponents? Yeah, it's just multiplication. So it's the same as a product. If I have 5 squared, it's 5 times what? 5 times what? 5, yeah, 5 times 5 is 5 squared. That's still just a product. You see what I mean? So everything we do in math is represented right here. Everything. Even a square root is really a product. I know that sounds weird, but it's true. Think about it. Square root of 16, what is it? Why is it 4? 4 times 4 is 16. You see what I mean? So all these are just, that's all we do in math. We only do 4 things. How can it be that hard? It's knowing what to do when, obviously, is the hard part, right? Because you can only do 4 things. That's it. So I'll use those words quite often, okay? Next word is a term. Okay, we're going to use one of these words to describe a term. How many terms? 0 or 1, right? That's your guess? 0 or 1 is probably your guess. It's okay, we're just guessing right now. How many terms? Probably 2, 3, or 1 is your guess. Okay? 2, 3, or 1 is your guess. How many terms? Either 4, 3, or 1 is your guess. Probably. Okay? How many terms? Either 1 or 2 or maybe 4. Okay, is your guess. How many terms? 3 or 6 is probably your guess. Okay? So, which guess do you think is right now? How many terms? 1. How many terms? 1. How many terms? 1. How many terms? 2. How many terms? 3. Okay, now you know what a term is, but you don't really maybe know the definition. How can I define the word term? It's a product. What does product mean? What does product mean? Multiplying. It's a product of numbers and or what? Variables. It's a product of numbers and or variables. That's a term. Write that down. A product of numbers and or variables. By the way, if I put a negative in front of that, does that change that being a term? Nope, still just one term. Still a product. Negative 3 times x times y. Okay? So a term is a product of numbers and or variables. This one doesn't have any variables. Is it still a product? Yeah, it's 2 times 1. What's 2 times 1? Still 2. right? Every single one of these, I could put a 1 in front of them if I wanted. So this is still a product, 2 times 1. And it's going to be one term. This is one term, this is one term, this is, so how do we separate terms? This is something else you want to write with term, okay? So the definition of term is what? A product of numbers and or variables. Okay, that's the definition. But how do we separate terms? Terms are separated by what? Positives or negatives, and sometimes equal signs, right? So write that in your notes. Terms are separated by positives and or negatives, and sometimes equal signs. When we said there's 3 terms here, these were separating the terms. Okay, I could change this to a minus, it's not gonna matter. This is separating the what? The terms. That's why there's 2 terms here and 3 terms here. Okay, so terms are pretty easy. Any questions on what a term is now? Okay, term's easy, right? Okay, let's go to monomial, binomial, and polynomial. These are really easy too if you understand the prefix. What's a prefix in English? What's a prefix in English? What is it? A base word? Is that what he said? It's what's in front of the what? What's come before the base word. That's why we call it a prefix, right? Pre meaning what? Before. So all of those are the same base word. I like that you said that. All of those are the same base word. Monomial, binomial, polynomial, right? They're all the same base word. But they have different what? Prefixes. What does the word mono or mon mean?
1,
What does bi mean? 2. What does poly mean?
3 or 1.
Many. You ever heard of polygamy? What does it mean?
Many wives.
Many wives. That's what it means. So really, poly just means many. So by the way, are binomials polynomials? Yes, there's more than what? 1. Okay. Are trinomials polynomials?
Yes.
Yes, that's more than 1. And I forgot that one. I should put that one on here. Sorry, let's put that one in there. Trinomial. Okay, because I'll use that term too. So mono is what? 1 what? Term. Very good. That's it. That's all it is. Monomial is 1 term. Binomial is 2 terms. Trinomial is 3 terms. And polynomial is what? Many terms. More than 1 term. So all trinomials are polynomials. Are all polynomials trinomials? No. A binomial is a polynomial. A quadrinomial is a polynomial. A quintinomial is a... I'm not making words up there. Real words. He was like, dude, you're just picking that up. No, it really is a quintinomial. Septinomial. That's the word. That's 7. All right, so that's terms, but usually we only go binomial, trinomial, monomial, and polynomial. We usually, once we get above 3, we usually don't keep counting. We just are like, those are polynomials. Okay? Any questions on those? Pretty easy, huh? Now comes the hard part, the degree. Okay, this is kind of hard. And oh, I need to write this down too. Leading coefficient. Descending order. Okay? All right. Sorry, I got to throw those down there. All right, let's talk about degree. This is where it gets kind of confusing. And at the same time, pretty easy. The degree is the sum of the exponents. What word am I using from the top? Sum, which means I'm going to add what? What did I say? The sum of the exponents of the variables of an individual term. Okay, write that in your notes. The sum of the exponents on the variables for an individual term. The sum of the exponents on a variable of an individual term. Now I assume you already know what exponents are. What are exponents? What is another word we use for exponents in math usually? It's the power, right? just the power, the thing that it's raised to, okay? So that is the exponent, okay? The sum of the exponents is implying I should do what with them? Add the exponents of only the what though? Of the variables, only the variables, the sum of the exponents of the variables, for each individual what? Term. Okay. So what is the degree of, so I'm going to write this outside. What is the degree of this term? 2 and what? 2 plus 1. How come I'm adding them? Sum, right? The sum of the exponents on the variables. 2 plus 1 is, what's 2 plus 1? 3. That's the degree. Everybody got it? It's not because of this 3. It's because of 2 plus what? 1. Everybody got it? Okay, so, Kavri, what's the degree on this one?
I don't know.
Try it.
Is it 2?
Okay, so again, I want to look at the exponents. Look at the exponents. Don't look at the coefficient. You're looking at the coefficient.
7?
Okay, good. Okay, she looked at the exponent. She's like, oh yeah, I got to look at the exponent. Don't look at the coefficient. That doesn't mean anything. It's these exponents that mean something. 3, 3, and always if there isn't anything sitting there, it's a what?
1.
It's a 1. So 3, 3, 1 is 7. Everybody got it now? Okay, let's go up here. This one's really tough. I forgot your name.
Alejandro.
Alejandro, what do you think this one is? If this is 3 and this is 7, what do you think that is?
0.
0, very good. Most kids miss that. They think it's 1. But is there any variable? No. By the way, can I write x to the 0 there? Sure, what is x to the 0? 1. Anything to the 0 is 1. We learned that the other day, right? So anything to the 0 is 1, so that's just 1 anyway, and that's just 2. But that means the exponent value is 0, therefore the degree is what? The degree is 0. So if there's not a variable, this is something you might want to write in your notes here by degree. If there's not a variable, the degree is what? 0. Okay? If there's no variable in the problem at all, the degree is 0. Okay? So that one has a degree of 0. Now we get a little tricky. We're going to talk about degree of a polynomial. The degree of a polynomial is the highest degreed term. The degree of a polynomial is the highest degreed term. One of the most missed questions on the ACT. What's the degree of this polynomial? It's 3. But a lot of kids want to put 6. What did they do? They added all the exponents, right? And you do that to find the degree of a monomial or individual term, right? That's what we were doing here. But these, notice, were monomials or individual terms. Over here we have how many terms? How many terms do we have? 1, 2, 3, what? 4. We have 4 terms. It's a, what do we call it? Polynomial. Yep, that's a polynomial. What's the degree of the polynomial? We just told you, degree of polynomial is highest degreed term. What's the highest degree of any individual term? 3. Okay, this 3 is the highest degree term. You with me on that? That's kind of tricky because you've been adding them all, right, when we have terms, but all of a sudden we're like, now I have a bunch of terms, don't add them all, right? Don't add them all. Add each individual term, whichever one's highest, that's the what? That's the degree, okay? The degree of the polynomial is the highest degree term. Everybody got that? Any questions? Questions? Okay. Want to see another example, or are we good? I'll show you another example when we do these, okay? Because it'll be the same type of thing. All right, like terms. What are like terms? You know what they are instinctively, but how do I define it? Think about that. So I got a question. Let's do this. What is this? What's this whole statement called? A what? Polynomial. Very good. What's the degree? 2. Why is the degree 2? The highest degree individual term anywhere in there is 2. Got it? So that's the degree of the polynomial. Okay, now, what are the like terms in this polynomial? You know them instinctively, right? But you don't know how to define it. How do I define like terms? They have the same variable and the same what? You said it right. Exponent. That's the key. So like terms have the same variables with the same exponential values. You want to write that in your notes. Like terms are terms in which they have the same variables with the same exponential values. So what are the like terms here? What's your name? No. Who are you? Yeah. Addison. And you are? Whitley. And you are? Jax. Jax, what are the like terms in this problem? Give me one pair of them. One pair of like terms.
3x squared and 4x squared.
Okay, now, he's doing something that we kind of do naturally, but it goes down to here, leading coefficient in descending order. What does descending mean? Like in general, the word descending, like if I descend off the mountain.
Down.
It goes down, so it starts what? High and goes down, okay? Starts high, goes down. That's all you're doing when we're doing descending order. We're going from the highest exponential values to the what? Lowest in alphabetical order, in case there's 2 variables, right? So you want to do that. Write that in your notes. Highest exponential values, this is descending order. By the way, this is also called, in your book, they call this standard form. Okay, so if you see standard form, it means the same thing as descending order. And standard form or descending order is going from what? Highest exponential value to what? Lowest exponential value. And Jax did that naturally when I said, hey, pick out the 2 like terms, right? He didn't pick out the 3 and the 1. Could he have? Yeah, sure, I didn't tell him not to. But our natural instinct is to go from what? Highest to what? Lowest. Now, when I add these like terms, this is something kind of tricky and something you probably want to put by like terms. When I add like terms or subtract like terms, what do I do with the coefficients? Oh, that's a word. Did I talk about coefficient? Oh, right here I do. What is a coefficient? I say that again, it's just a term it's a word we use in math all the time. What does it mean? What is a coefficient?
So like on -2x, the coefficient is 2.
The coefficient is the -2, actually.
Yeah.
Okay? So it's the number where?
Before the
In front of the variable, or the number multiplying the variable. Okay? The number being multiplied to the variable, or the number in front of the variable, is the what? What? Efficient. Okay? Coefficient. So we're adding these two. 4x squared minus 3x squared. How many x squareds do we have? What's 4 minus 3? 4 minus 3 is 1x squared. Okay? Notice I do not, and this is what you want to put with like terms, do not change the exponents when you add or subtract like terms. Do not change the exponents when you add or subtract like terms. Okay? A lot of kids I've seen write this, and they'll put, okay, that's 1x to the 4th. What did they do? They added the 2 and the what? 2. Don't do that. Okay? Make sure when you add like terms, you keep the same exponential value. You don't change the exponents. You only add the like terms, right? Okay, so I'm only adding those. Okay, now what? What's the next set of like terms in descending order or standard form? Derek, what's the next like terms in descending order?
-2x.
Good. And what? And add those, and what do I get, Derek?
5x.
5x. Notice he didn't change the exponent, he just said 5x, right? That's what we want to do. 5x is the next one. Okay, the last ones. What's your name in the back?
Sid.
Sid. What are the last ones?
3 and
3 and 1. And it's add here this time, so 3 plus 1 is
1.
4. This was a polynomial, what's this? Trinomial. What is the degree of the answer? 2. What is the leading coefficient? 1. Where did the 1 come from? It's the number in front of the x squared. So leading coefficient, this is the next thing we're talking about. Leading coefficient is what? The number in front of the highest degreed term. The number in front of the highest degreed term. What if there's not one there? This one didn't have a number in front.
It's one.
It's 1. Okay? It's the number in front of the highest degreed term. If there's not one there, it's 1. Okay? So that's a leading coefficient. Now we're going to learn distribution. We're going to do that outside though, looking at the car. So, and then you can take your mask off for a second too. So we'll do that next. So you can stop the video.